Hey everybody, welcome to lesson number 4, Matrices and Systems of Equations. Let's talk about what a matrix is. Matrix is a kind of like a table of values, and it's going to have dimensions based on how tall and how long it is. Right? So depending on how many rows or how tall this thing happens to be would be our M coordinate, and then however many columns or how wide it happens to be would be our N value. And those would be dimensions. And then we also have a pretty easy to use system to figure out what coordinate or which entry we're talking about. Right? So if we're talking about, say, this one right here, we know that it's in the third row and the second column because it has a little subtext here, 3, 2. First would be your row, second would be your column, which matches the m by n system. Okay, so that's how we can figure out how many or what the dimensions of a matrix is. So let's take a look at these examples. I don't think it's necessary to copy these for right now. Okay, we have this first one that it's 1, 2, 3 entries tall and only 1 entry wide, right? So it's 3 by 1. Here we have 1, 2 entries tall and 1, 2, 3, 4 entries wide. And the last one here, there's 2 by 2. Okay, so there are some here. I don't think, again, you don't have to necessarily write this down. I would pause the video and just write down what your solutions would be. So go ahead and do that now. Alright, let's check them out. This first one is only 1 tall and 4 wide, so that's a 1 by 4 matrix. Problem B is 3 deep and 2 wide, so 3 by 2. And for C, we have 2 tall and 3 wide. So those are the dimensions of a matrix. That's what a matrix is. Let's talk about how we can use matrices. Okay, and we'll get those systems of equations involved. Right? So in the past, we've had system of 2 equations with x and y, and those are pretty easy. We used elimination and substitution, and we could solve those, right? And then we looked at the systems in 3 variables, and that took us quite a lot of effort, and sometimes we would mess stuff up, and it was tough, right? But what we can use a matrix for is, I mean, we can use it with 2 by 2s or anything less, but we like to use them for one particular occasion is when we have a system in 3 variables or more. And what we can do is just take the coefficients of each of our x's, our y's, our z's, and we can write them in a corresponding columns, right? This would be our x column, our y, and our z. And then we also have our solution that we can work with that will keep separated over on this other side. And we call that an augmented matrix. Okay, so you notice how each of these coefficients lined up. We were missing a z here, so we filled in with a 0. So you're going to try this one right here. I would like for you to write it as an augmented matrix and then state the dimensions. As you can see, I did that here with it being 3 deep and 1, 2, 3, 4 entries wide. So pause the video and write this one out as an augmented matrix. Alright, let's check out your answer. We have 6, 0, and negative 8, negative 3, 5, 3, 8, negative 6, negative 4, and our solution side would be 24, negative 3, and negative 14. I already knew it was going to be 3 tall, and it looks like it's 4 long, so that's 3 by 4. Right, pretty easy to write augmented matrices, and it makes sense. We're just rewriting our system as a matrix. And what we're going to do now is start using what are called elementary row operations. because not only do we want to rewrite the systems, we want to be able to solve them. So pause the video, write these down, and then we'll discuss them. Alright, so the first thing we can do is interchange, which is just switching two rows. Right, so let's say I wanted these two rows to switch with each other. I can do that in one move. That's allowed. Second thing we can do is we can multiply an entire row by a non-zero constant. There are a couple of options, right? We can use whole numbers, no problem. If we want to change a number down to 1, sometimes we can divide with a fraction, right? That's still multiplying a fraction and dividing, same idea. And then there's other times where we have negatives that we might want to become positive. We can use a negative number, right? So those are some things to keep in mind for our non-zero constant. By the way, if we multiply by 0, it's just going to wipe out everything, and that doesn't really help in solving. And if we multiply by 1, nothing changes. So we usually don't multiply by 1 either. And our third option, add a multiple of one row to another. So it's actually kind of combining option 2, and then option 3 is adding. Let's say I have like a negative and a positive. A good way to eliminate to make zeros would be to add those rows together. And sometimes I need multiple of these things to add to this to eliminate. Now that all kind of sounds a little crazy right now. We'll see this all in action in a problem in a moment. But this is what we want to try to get our matrix to look like. Okay, we want 1s going diagonally from the top left down to the right bottom corner on our X, Y, and Z side. And then we want 0s to be directly underneath. Then we have these little hashtag marks right here, which those could be any number, right? They could be anything. And then we're going to have our solutions. So this is what we want our matrix to look like after using these operations up here, right? And here's what happens. If these hashtags up here are all zeros, then we can very simply see that our X would equal A, our Y would equal B, our Z would equal C. Right? That's very clear. There's nothing else in those positions, so it would have to be equal. But if we get these little hashtag things to be not 0, like maybe like a 3, a 5, a -2, whatever it happens to be, then we can start using back substitution, which I'll explain more in detail when we come across it. But basically, we already know what Z would be equal to, so we'll be plugging in that Z value and start to solve. And then we'll continue it up here as well. So yes, it's a lot of information that we're going to be keeping in mind. But hopefully you have those row operations in mind right now. Okay, take a second and pause the video to copy this down. We're going to do our first solving using matrix operations in a minute. Alright, let's see. We want to rewrite this as an augmented matrix. By the way, if at any point you want to pause this to copy down or rewind to figure out what exactly happened, go for it. Right, so we're going to change this to an augmented matrix. -1, 4, 1, -5, -5, +5, -5, 4, -1, -5, oops, I'm sorry, that should be a 2, 19, and -20. Alright, so we just rewrote as an augmented matrix. So now we're going to do our very first row operation. I'm trying to get this right here to be a 1, which we're pretty close. It's -1, so we're on the right track here. And I want these two underneath to become zeros. So my first operation, I can see if I take this row and I add it to this row down here, the -1 and +1 should eliminate and give me 0 down here. So that's what I'm going to do. And the way that we're going to write it is I'm going to make a note. I'm taking row 1 and I'm adding it to whatever row 3 is. This is something that I will be checking to see, what is it you're doing. Okay, and that's going to help not only you remember, but it will help me figure out if you happen to make an error, where errors are. So we want to make sure that we're writing down what we're doing. So we haven't touched the top row or the middle row, but we combined row 1 and row 3. So if I take -1 and 1, we get 0, -5 and 5. Oops, that becomes 0, and -5 plus -1 is -6. Then we also have our solutions, which we can combine, which will give us -18. That's our first step that we take for this particular problem, right? We're trying to get zeros, and we're still in pretty good position, right? Because now we have a 6 with the zeros on this side, which is close to what we wanted. So another thing that we suggest that we can do is multiply by a negative to make that become positive, and by a fraction to make this become 1. So if we used -1/6, that will change to +1, which is what we want. So we're doing -1/6 of row 3. So let's do that. 0 times -1/6 is 0. That happens twice. We just picked this out in specific to make that become 1. And then -18 times -1/6 is +3. And then I'm going to fill in the rest of this info that we haven't used yet. So now we've got a 1 where we want it. And we also have a 1 right here that we'll deal with in a minute. But first, I want to make this 4 disappear. So how I'm going to do that is I'm going to add 4 of these rows, row 1, with row 2. 4 row 1s added to row 2. So let's see what happens. -1 times 4 is -4 plus 4. That gives us the 0 we wanted. -5 times 4 is -20 plus -5 is -25. And then we got that same thing. -5 and 4 is -20. Plus 4 is -16. And then last we have our solutions. 2 times 4 is 8 plus 19 is 27. And then again, we haven't touched this bottom row. Alright, now we're in even better shape. I'm thinking about maybe trying to eliminate this 16 up here. Actually, we won't even do that. Here's something that we can do. I need this 25 to become a 1. Actually, no, we won't do that. We'll go with what my notes say. I think this makes more sense. We want this 1 to become positive, so let's just take care of that right now. If we multiply by -1, that -1 becomes positive. Same thing with these -5s. They both become positive. And our +2 changes to -2. Haven't touched this stuff yet. Alright, so this is the next thing that I decided to do. I'm going to get rid of this 16. And I'm going to do that by adding 16 of these 1s to that -16. So that means I need 16 row 3s plus row 2. So just recopying row 1. Here, if I take 0, 16 gives me 0, plus 0 is 0. Again, 0 plus 16 times 16 is 0 plus negative 25. So those didn't change. 1 times 16 minus 16, that becomes 0. 3 times 16 is 48. Plus 27 is 75. And then we didn't use this stuff at all, or change this stuff, I should have said. Okay, so now we're in really decent shape because we've got a 1 here with all zeros, we've got a 1 here, and I can make that become a 1 pretty easily. And I know I had said that we'd deal with that in a minute. Right, we're going to get rid of that 25 now. So I'm going to divide by 25 to make that become 1, and negative to get rid of that negative. So let's see, 0 here, negative 25 divided by negative 25 is 1, and then 75 divided by negative 25 is negative 3. And then we have 0, 0, 1, and 3. And hey, check this out. This is what we were hoping for. Right? These are all zeros here, and we've got 1s all the way down. So now we can actually start solving this using arithmetic at this point. Right? We know right here, this is our z column, z equals 3. That was easy. Here we have our y column. We have no x's and no z's. We do have y equal to negative 3. So that was pretty easy. But now we have some things in our y and z columns along with our x. So this is what's happening. We've got x plus 5y plus 5z equal to negative 2. But luckily, because we already know some of these things, we can substitute back in. We are trying to find x. 5 times negative 3 plus 5 times positive 3. And then let's see, this is negative 15, positive 15. Those basically eliminate each other, and we get, oops, right off screen, negative 2. I'm going to write that in a coordinate. Negative 2 is first, negative 3 is second, and then z last. So, yeah, this was probably a little difficult to just watch being done. It's a lot easier if you're in class and you can ask questions, but basically, we changed this original matrix into just coefficients. And then we started thinking about how we can eliminate by just either adding or adding multiples of, right? That's what these first couple steps were. We also used the trick of how do I make a number become 1? We divide by that number, including any negatives to reverse the negatives. So a lot of these things happened a couple of times reoccurring, right? We had to multiply and then add to eliminate. We had to multiply and add to eliminate. We had to multiply by a negative and reciprocal to make it become 1. So a lot of these tricks are kind of repeated. And then we get to a certain point where we could use that back substitution. So it's that favorite time of the video where you get to try one of these on your own. Really, pause the video, try it out, see if you get it right. You might surprise yourself and find out that this isn't that bad. Alright, let's see how you did. This is it, by the way. This is the last problem for the video. Okay, we want to start off by rewriting this as an augmented matrix. So, here we go. If you got to there, you're not doing too bad so far, right? That's getting you some partial credit at the very least. Then we want to think about, all right, how can we start making numbers disappear? Well, I can see that I have a positive 5 and a negative 5, so by adding these together, I'll be able to get rid of that 5 here. So let's do that. Let's add row 3 plus row 1 together. Negative 2 and negative 4 is negative 6. 5 and negative 5 is 0. 2 and negative 1 is 1. 4 and 18 is 22. Haven't touched these yet. By the way, you might have chose a different first move. That happens, right? Like you might have done this move next. I'm going to get rid of this right here. I'm also going to get rid of it here as well. So I'm going to add row 3 to row 2 now. So it's possible that you had these two switched. That's fine. Doesn't really matter. You can change the order around. So let's see. Negative 2 and negative 2 is negative 4. Positive 5, negative 5 is 0. Positive 2, negative 2 is 0. 4 and 12, 16. Haven't used this stuff yet. Okay, first couple steps not too bad. How can we make this negative 4 become a 1? We'll multiply by negative 1/4. So let's see. This stuff all stays the same. This becomes 1, 0, 0. Negative 1/4 times 16 is negative 4. And then we haven't touched these yet. There's something we can do to get rid of the 6 right here. Alright, we can take 6 of these and add it here. So we'll take 6 of row 2 and add it to row 1. Why am I choosing to work with row 2 and not row 3 at this point? A couple of reasons. It's easier to just do 6 times 1. That's a lot easier. But then also, I've already got rid of something here. And I noticed that I've got nothing here. So these aren't going to affect each other. Right? So I'm not changing stuff back and making more work for myself for later if I work with more zeros. So anyways, 6 times 1 is 6 plus negative 6. That becomes 0. 0 times 6 and plus 0. 0 times 6 is 0 again plus 1. So that didn't change. Negative 4 times 6 is negative 24. Plus 22 is negative 2. And then we'll copy all this stuff down. Alright, we're getting there. Let's see if we can get rid of this 2. We'll add 2 of these down here. So 2 row 2 plus row 3. 2 times 1 is 2 plus negative 2 is 0. 0 plus 5. 0 plus 2. Negative 4 times 2 is negative 8 plus 4 is negative 4. And then we've got to rewrite all this stuff. What else can we do here? It looks like we can get rid of this 2 by multiplying negative 2 times 1 and then adding this whole thing together, right? Again, our zeros aren't going to affect anything. 0 and the 5, nothing's going to change. 1 times negative 2 is negative 2, plus 2 is 0. Negative 2 times negative 2 is positive 4, plus 4 is 0. Okay, so that's not a problem. We're allowed to have 0 be a solution. And we're almost there, right? If we make that a 1, then we're pretty much done. We can do that by multiplying by 1/5. Right? 0, 1, 0, 0. No problems there. And I'm just going to repeat these ones. And if we want this to look the way that it's supposed to, we're going to do some quick row changes. Right? I need this one to move up. I need this one to move up, and this one to move to the very bottom, right? Because that should be at the very top, in the middle. That should be the last. So I'm just going to show what I did. I moved the middle one up, the bottom one to the middle, and then I'm going to move this third one over all the way to the bottom. This is what we'll have. 1, 0, 0, negative 4 goes at the top. 0, 1, 0, 0 moves up 1, and this top one's going to move down. So now we have our solutions, right? This is x, y, and z equal to, right? There's nothing here for x and z. I'm sorry, for y and z, right? So we've got x equaling negative 4. Here we've got y equals 0 and z equals negative 2. We want to write that out in coordinate form. So here's your solution. So that's how we solve using matrices, right? I think it's just a tad bit easier than having to rewrite all of these variables over and over and over. It just saves you a little bit of time. Hand doesn't cramp up quite as bad. But that's enough of me blabbing now. That's the end of the video. Come back and check out lesson 5. See you later.